Abbiamo sentito che ci saranno quindi dei trial clinici che si stanno preparando per le nostre patologie e questo, diciamo, rinforza la necessità di ottenere una diagnosi e una diagnosi esatta di quelle che sono le mutazioni genetiche. Introduciamo quindi il professor Andréasson, che viene dalla Svezia, da Lund, e che ci parlerà della diagnostica, in particolare dell'ERG e dei test del colore per le nostre patologie. Benvenuto. Welcome.
Thanks a lot for inviting me to this meeting. I really appreciate that. And I must be honest, I didn't know about this group before, for a couple of months ago. Thanks a lot. I'm also, must say from the beginning, I'm more than a clinician. I appreciate all of the work during the year as a group in Tübingen. Susan Kohler helped us a lot with DNA examination, many patients. Thanks a lot. So from my point of view, I want to talk about ERG, and that's something else, perhaps. But you are a group. In south part of Sweden, Lund, we have a special looking at patients from different parts of Sweden, some from Norway, as clinical patients. And we are a group with clinicians, nurses, secretary, for clinical work, about 20 persons who work together. And besides that, also we have a clinical research part, and also besides that, we have laboratory. But the usually main reason for work is retinitis pigmentosa. So now I come here about acromatopsia is one part of this. I just say what I present here is what many do together. So when I talk about acromatopsia in Sweden and Scandinavia, in fact, and talk about electrophysiology, one thing we have a problem in Scandinavia during the last 20 years is to get the diagnose. Diagnose is important to understand the patient. I just give you two things that for understand that. When we started, there were so many people around our area that were not what we call visual handicap, but unknown vision loss. So about 20 years ago, when we started to look at it, we suddenly see that there were many people in our area infected with achromatopsia. And what does it mean for a patient? I can give you two reports. And you know, of course, better than me about that. But just to understand that also the diagnosis could be important. I remember a 10-year-old boy traveling around in Sweden, and the parents get angry at him. Why doesn't want to go swim during the summertime? Why doesn't he like to read? And I thought was someone crazy. He didn't understand it. And the family didn't understand it. But when he came to us about the age of 10 years, he get the diagnosis, and he suddenly recognized, oh, that's the way our people see. And he got the glasses, understand he shouldn't use his rods. After that, the road, he tell everyone, I know how I could see and better understand my vision. I see better with rods. It took 10 years, and it was a great thing for his family. I tell you also about 1 year ago, I was in Uppsala. We do some of our clinical electrophysiology there. And there was a family with a 1-year-old girl who had problem with nystagmus. And the mother and father was really sad because they didn't want to look at him, look at her. And we did the ERG and saw that she has no cones. And after that, we said, before we get in and talk to the family, we turn off the light. And after 10 minutes, the father say, the girl is suddenly look at me again. And that's mean, but we don't, as parents or people around, don't really understand from the beginning what is vision. And the people who have this problem have sometimes problem to understand how our people see. So I just want to point out that the diagnosis could also be important for the family, as you know better than me. I want to, during this minutes here, talk something about electrophysiology. And so, when I look at the eye, I look at the eye as though I have one thing to do. It should convert light to electricity. In fact, when light comes into the eye, it comes to rods and cones, and you get some electricity. And that's the reason why I think it's interesting to measure voltage in the eye. Now when I talk about this and talk about ERG, I think about two things first. We're going to talk about doing the standard ERG to understand, to examine patients who have no cones, perhaps. But also today want to show that there can be some pitfalls. For example, it's important when I send DNA, is this really not a cone dystrophy who rapidly deteriorate and you lose your vision, or is it more stationary? The way to understand the vision better when you do ERG. So when we do an ERG, you can do it a different way, but we do it, and usually when it's more than 6 years old, you do it in local anesthesia. Otherwise, now more and more children come with us. We do it during general anesthesia. You put a lens on the eye, and this lens has three things to do. It keeps the eyelids from each other. Eyelids from each other. And you also put a lens on the eye. You see the lens over here. And there are some metallic on the lens. This is the lens they want to measure the electricity in the eye. And as you showed before, when you want to measure, what are you going to measure? We talked about before that this is where you have all the cones and rods. And cones you have, as it's heard before, mostly in the macular region. But you should also know that more than 90% of the cones is outside macular region. So when you measure the function in the retina, even if you have a large macular degeneration, you get rather nice signals. So when you talk about cones and rods, most of the cones density in macula, but when you measure the cones, most are in fact outside the macular region. And here on, you can also put the rods on the side. You get some ideas. You have two systems. It doesn't work at the same time. Sorry. So when you usually do in the children, and I don't only say in the children, because some problem we have at the eye clinic, we have lots of sophisticated equipment when you work in a clinic, but most of these things you have are used to people who can collaborate, who can co-work. But if you have elderly people, you have handicapped people, and you have children, you must have a problem to do it, but sometimes you must do it in general anesthesia. So we use very often, every week, we do children under general anesthesia, put the lens on, measure how retina is working. And there's some pitfall even here. If you heard about it before, but the light is coming into the eye, get through retina, go down to the rods. This child now has been in darkness for at least 40 minutes, and you have a lens on the eye, and you put a light, a blue light, for only 20 microseconds. That's a very short time, and you get a nice response. And you do it twice to be sure about reproducibility. In this case, you can really be sure, in an objective way, the rods are working in this child. Only 2 signals, a clean response. You do the same thing, you get to red light. Red light has another wavelength, more like to the cones. And then you get a small signal before the rod's response, and you get a clean signal of one stimulation that the cones is working. This is an objective way. If its retina is normal. And also sometimes you want, especially nowadays, you see the separate cone responses, separate rod response in a nice way. You also want to know the total response way. Especially as we look at the different type of retinitis pigmentosa, you want to follow the way of deterioration. And then if you put in darkness white light, you get a nice single response. And then you can do a different way here. You can put background to look at the different rock cones, but you're not going to do that. So when you're doing children, I think it's important, at least in Scandinavia, if you have a child with unknown vision loss, don't let them go on the eye clinic to 10, 12 years old. To examine them early, you must be careful of different things. And that is important when you do ERG during anesthesia. You must be aware of what type of anesthesia you're doing. How can anesthesia affect the way you're doing? We have published what we are doing, and I don't know that Günther Niemeyer in Switzerland and even the group in Oregon uses same type of anesthesia as we are doing to get a so clear response as possible. And then you also must follow up. You must get the normals for different type of age. You see, ERD in us taken a year, you get so clean response as possible, you must be normative. We showed this picture before. This is, in fact, the red. The cone doesn't work. And you should just know, you said 90% of the cones are outside the macula, but also about 70% of the function in retina is rods. And you don't use them. Perhaps some use it now, but that's a way to do it. Okay, now we have a child here. On the top, you see a nice response for the blue light, that for normal, rod is working. You see on the yellow on the bottom, you see to the left, a nice response on the rods. And what's second to right should be for the red light. And that should be a little way before, but I'm missing something. And you see in the bottom to the left, just a straight line. So the cone doesn't work. So if you have an unknown vision loss, I usually tell the parents, the patient, if you go out, this is how the eye work when it's light outside. So the problem about glare, about visual acuity, and perhaps also color blindness, but not the worst thing. But you get an objective way. This is what was, let's say, a classic type to understand how you can do it in easily objective way, but not the whole thing. Anyway, as to say, I never show a picture of a patient, but this young boy from Norway who was running around to different places and said, please Stan, show it for me. He also sent me a letter. The only thing we did, he get the diagnosis. He was misunderstanding in many years, and when he get the diagnosis, he suddenly could play football again, use his dark glasses. He just say, we look into treatment, but also even ERG is good to understand what the visual handicap is. Some told me here, and I make it very shortly, Sten, could you please tell me something when you now say that these children have acromatopsia? In the literature, there are written also about different plates. I think it's getting old because we have a molecular entity much before. But as we have a question about that, I was many years ago working in Boston, ERG, and there was a man called Elliot Person. And at that time, they wanted to know if you ever have a boy, even if for acromatopsia, was it a recessive or was it X-linked? And just to show you, as I've been asked before, there are a test called blue cone monochromaticity test. At that time was the main reason, perhaps to see was a blue cone and not a blue cone, and you can test not young teen or 2, 3 years old, but teenager, and there was some help to understand if there could be some blue cone left. Today it's better to send the blood to tubing or whatever, but it was at that time it was important, and I know you have asked about it. So it could, for a family, important is this an X-linked or recessive. But in his plate, there was one Mayo place. He writes, if you're going to use this test, the cone response must be less than 1.5 microvolt. What does this mean? He said that the cone response must be less than 1.5 microvolt. And normally we have about 40, 50 microvolt. What he said was an important thing is a different type of cone dystrophy. And not all is acromatopsia. There are types of cone deterioration, but it's not acromatopsia, and that's important to pick them out because they're different prognosis. And I can also say, for example, looking at the group of retinitis pigmentosa, you say we perhaps lost lots of cones in some patients, but in patient with retinitis pigmentosa, I know you can walk around here in Venice, and you can read a paper with only 1% of a cone left. So there was a need to understand if you still have some cone left. I can tell you this was another child, we get no response at all, and they started to do tactile response on her, but to do tactile writing. But she said she's good to seeing. So when you do testing today, you must also have the possibility to measure residual small response. To have 1 microvolt left, it means that you see something. It's also important for when you're looking now, what we're talking about, if we do an ERG for achromatopsia, it could be, for example, but I will send a report, no cone response left, but there could be someone. And if there's someone response left, it could be bad impact for patient. It could be cone generation. So doing ERG and look at achromatopsia, we try to do the best to see are there really any cones left there. And you done just a straight line. If you do a ERG recorder, you must see how sensitive are the tests. It could be that if there are 10 microvolt left, it could be bad for a patient because then it could be a cone road generation. I just say that there could be some pitfalls when we're doing ERG. But if you want to have a group of stationary disorder or progressive disorder. I agree with you that perhaps are very slowly progressive in achromatopsia. But our other retinal disorder close to this was rapid disorder. You must be sure what you're dealing with. About 6 so this was a group for a dominant cone road disorder, and if we look at these children, they could look at achromatopsia, have a very small response, but this is a more sad disorder. About 6 or 7 years ago, I was, this is the second time in this place, I was in Padua, Venetia, at a meeting. It was an Ulster meeting. And just before that meeting, I have examined a patient, a small girl, 4 years old, normal, almost normal raw response, but no cone response at all. I didn't know at that time the girl was normal, developed at that age, but looks at acromatopsia. But after 2 years, she got total blind. And that was also another disorder we call ulcer disorder that could be a different thing. So what I said this thing is, doing ERG helps us to understand how the rods and cones are working. It helps us to better define achromatopsia, and with the genetic help you could also help about blue achromatopsia. But also when you do ERG, so you doesn't get disappointed of people doing that, you should pressure on. Are you sure it's not a cone duration? And it's possible today to figure out that. This was something more doing ERG and children to pick up this. I think I stopped there.